Archaeologists opened a 5,500-year-old cemetery near Lake Baikal, and the graves gave them a problem. Children, teenagers, families buried close together. The dead looked clustered, almost rushed, as if one bad season had swallowed the camp. For years, the bones told the same story without naming the killer. Something hit these people hard. The site sat in East Siberia, beside one of the deepest lakes on Earth. The people who lived there hunted, fished, gathered plants, moved with the seasons, and slept under skies full of smoke and stars. Their stories vanished. Their shelters vanished. They left teeth, and teeth can keep secrets. Inside a tooth is soft pulp, a tiny sealed room of blood vessels and nerves. When infection floods the blood before death, pieces of that microbe can get trapped there. Thousands of years later, a lab can crack open the tooth and read the leftovers like a crime scene note. Bone can tell age, diet, injury, and ancestry. Teeth can tell who was inside the blood. So researchers sampled remains from 4 hunter-gatherer cemeteries around Lake Baikal. They were looking for ancient DNA. They found plague. The bacterium was Yersinia pestis, the same species behind the Black Death, and it showed up again and again and again. 18 of 46 sampled people carried traces of it. That is about 40%. Picture 46 simple grave markers on a board, then mark 18 of them with the same invisible killer. One infected skeleton can be an accident of history. 18 infected people, spread through cemeteries with strange burial patterns, looks like an outbreak. That is why this discovery matters. It moves deadly plague far deeper into human history. The argument does not rest on one dramatic clue. It stacks clues: age patterns, burial timing, family relationships, bacterial DNA. Each one points toward the same event from a different angle. The Black Death tore through Europe in the 1300s. It rode through crowded towns, trade routes, rodents, and fleas. That version of plague became the nightmare everyone remembers. Lake Baikal came much earlier. These people lived more than 3,000 years before the Black Death. Their world was lake water, smoke, tools, hides, fish bones, and trails through cold forest. So the old question was simple: could early plague really kill like that? For a long time, the answer looked uncertain. Ancient plague strains seemed to lack some of the genetic tools later plague used to spread so efficiently through fleas. Then the Siberian evidence landed on the table. The graves already looked like a disaster. The radiocarbon dates squeezed many burials into short windows. The DNA linked some of the dead as relatives. A family tree appeared under the dirt, close kin resting near close kin, as if one sickness moved through households instead of picking strangers at random. Then, the teeth gave up the pathogen. The picture sharpened. This early plague already had a blade. It had teeth. One strange clue makes it even darker. The ancient strains carried a superantigen, a toxin-producing genetic factor that later historic plague strains appear to lack. A superantigen can shove the immune system into panic. The body tries to fight, then floods itself with inflammation. The defense becomes part of the damage. Think of it like a smoke alarm wired to the whole house. A small spark trips every bell at once. The noise meant to save you becomes the thing that breaks the room. That may help explain how an early form of plague could burn through small communities before the classic rat and flea story took over. Picture the camp: a cold lake, smoke from a fire, fish drying on racks, children carrying sticks, adults cleaning hides, cutting meat, sharing tools. Nearby, marmots dig through the ground. Marmots can still carry plague today, and researchers point to wild rodents as a possible bridge between the bacterium and these human groups. Maybe someone handled a sick animal. Maybe one infection entered a shelter. Maybe a family cared for a feverish child and carried the same danger home. In a small camp, care means closeness. Someone brings water, someone shares a blanket, someone sleeps beside the sick, because leaving them alone would feel impossible. That is how a hidden microbe turns kindness into a path. The first moment is gone. The pattern stayed. Burials close in time, relatives side by side, too many young bodies, plague DNA in the teeth. This is the part that changes the whole story. We often blame epidemics on civilization, Big towns, animal pens, trade roads, crowds, waste. Those things matter. They turn sparks into wildfires. Lake Baikal shows that the spark already existed. Small groups could suffer lethal outbreaks long before empires drew maps or merchants crossed continents. Plague reached humans before they built cities. It found people at the edge of a lake. Those people had no word for bacteria. They could see a child grow weak. They could feel a fever. They could dig a grave. They could bury a parent beside a child and hope the sickness stopped there. Then, silence covered the camp for 5,500 years. The detectives arrived late. Archaeologists read the graves. Radiocarbon dating read the clock. Kinship DNA read the family tree. Pathogen DNA named the killer. Each tool added one piece. The grave said who died. The date said when. The family tree said who stood close in life. The pathogen said what moved through them, all from remains smaller than a coin. A tooth became the witness, and the witness said plague. So when people picture plague beginning in medieval Europe, Lake Baikal pulls the camera back, way back, past castles, past written histories, past the first great cities, into a cold Siberian landscape where families once lived, died, and left one of the oldest outbreak scenes ever found. The Black Death becomes a later chapter in a much older story, and one of the earliest pages was hidden in children's teeth. For more strange science and history stories, subscribe.